How many of you guys took economics? Okay, so we're going to do some derivative applications to economics. Really simple, straightforward. We've got three functions. You've got a cost function, a revenue function, and a profit function. So the rates of change of each of those, the derivatives, are called the marginal cost, marginal revenue, and the marginal profit. So we'll look at, well, what do those mean and how do they apply? So we've got a product and we've got a cost function for this product. This is how much it costs to make this product. So we've got, just looking at this equation, you've got a plus 2,000 at the end. So if you didn't make a single product, it's still going to cost you $2,000. That's probably just the setup for whatever you're going to be creating. And then it looks like, for the most part, it's costing around $40 for each unit. And then as you do more and more, you subtract a tiny little bit. So the more you make of this, the more efficient you are, you're going to be saving some money, which makes sense because that's how most things are. If you can make a lot of something, it's going to be cheaper to make than if you only have to make one or two. If each item sells for $80, find the revenue function. Well, the revenue function is just going to be 80x, because if each one sells for $80, you sell 5 of them, you're going to get $400 of revenue. Now, your profit function is always going to be your revenue subtract your cost. So we can say, yeah, this is on page 47, yes. 47. So your profit is always going to be your revenue minus your cost. In this case, your revenue function was 80x minus your cost function, which I'll put in brackets here, 40x minus 0.02x squared plus 2,000. And if you wanted, you could simplify this. Go back. Oh. So we're going to imagine a situation where 100 units are being manufactured, and we want to find the marginal revenue. Now, marginal revenue is an estimate. So when you take the derivative of your revenue function, and since our revenue function was 80x, the derivative is going to be 80. And this is an estimate to how much more revenue you will receive if you sell one more. Well, since they were all selling for 80, if you sold one more, you would probably expect to get $80 more. And in this case, the derivative is better than an estimate, it's exact. It's exactly 80. So this is telling you that if you sold one more, you'd expect to get around $80 in, which we know is the case. But in our second function here, our marginal cost, if we would do the derivative of that, so our cost function was 40x, so that'll be 40. Was it minus or plus here? Plus 0.2, so it'll be plus 0.04x once you do the derivative, and then the derivative of the minus 2,000 would go away. Let's see, do we got everything? Yes. So according to this, yeah.
For the original function, it was minus.
I thought it was a minus somewhere, but where did I? Oh, I was doing the derivative of my profit function. That's what I went wrong. Okay. So, yes. I was looking at my profit function. This should be a minus sign. That makes more sense. So now if we plug in 100 here, this becomes 40 minus 0.04 times 100 will be 4. This is an estimate. It's saying if you've already produced 100 and you go back to your machine and say, let's do one more, how much would it have cost us to make one more? It's an estimate that it would cost $36 to produce that next one. If we actually want to find what is the actual cost of producing the 101st unit, what we'd have to do is we'd have to figure out what is the actual cost of producing 101 units, what is the actual cost of producing 100 units. So if we go to our equation, which was 40 times x minus 0.02 times x squared plus 2,000, and plug that into our calculator, this would be the total cost of according to our cost function, this would be the total cost of producing 101 items. If we wanted to find out what would it have cost to produce 100 items, we put this into our calculator, we get 5,800. So if we look at what happens if we subtracted those two, does it make sense if I take the total cost of 101 items and subtracted the total cost of 100 items, what I'll be left with is just the cost for producing that 101st item. So if I take those two and subtract them, do you see that I get $35.98? That is the actual cost of producing the 101st item. Now, that was a lot of math and a lot of calculations we had to do to get that $35.98. Once we've got our marginal cost function, which is just the derivative of the cost function, how easy was it to plug that in to get an estimate? And how close was our estimate? It was off by 2 cents. So what your derivative does for your marginal cost and your marginal revenue and your marginal profit is it gives you an estimate, a really good estimate for what is the cost going to be if you produced one more, or what's the profit going to be if you produced one more. So here our marginal profit, this is the one that I accidentally did before. If we do the derivative of this, if you produced, how much profit would you make if you made one more? You'd make 44, which kind of makes sense because your revenue is 80. Our estimate for the cost was 36 for that 101st one. And so our estimated profit would be 44. Where did I get this equation? Oh, the P of 100 is because for all of these questions, for all of these ones, when 100 units are being manufactured, you're trying to figure out what it would be to produce the 101st. Okay? So when I plug in 100 into my marginal profit, it's telling me that if I did one more, that's what I could expect. And part of the reason for that is, what is a derivative? as far as a function goes. Derivative is slope, okay? And so if I got a slope of 44, what does that mean? Well, I could write it as 44 over 1, which means that we would have a rise of 44 and a run of 1. And so if we had some function and we had a run of 1 and a rise of 44, can you see how that's saying if you moved over from 100 to 101, you'd have to go 1 to the right. And how much are we going up then as an estimate? We're going up 44. So it's giving us an estimate that when we produce 1 more, we should get 44 more. But it's just an estimate because instead of actually being this point, what we've done is we just figured out the slope of the tangent to that function. But it becomes a good estimate.